So where would sine or cosine actually raise their heads in a mathematics problem? Well, basically, maybe you have a right angled triangle and you're trying to find out the length of a side, given that you know maybe one of the angles and one of the other sides. Let's say this is 3 centimeters long. Using trigonometry, I can now work out what x must be. People refer to this as SOHCAHTOA sometimes. So you label basically you're going to label the sides as what you have with respect to the angles. In this case, we have the opposite and the hypotenuse. And I was taught this in school. I think this is a terrible way to remember it, really. But SOHCAHTOA. So it's like socks and toes, I guess. And basically this sort of tells you that sine links with O and H, cos links with A and H, and T links with O and A. So sine, cos, and tan. The other two are the sides that you deal with if you're trying to remember which way around it is. That's fine. That's all well and good if you don't have an intuitive knowledge of what sine and cosine are doing. But just kind of remember sine is a ratio of the opposite to the hypotenuse, and know what the graph of that looks like, and why sine of 0 is 0 and stuff like that. It's kind of more intuitive. Remember the tan must be, drawing an isosceles triangle maybe will help you remember which way around it goes as well. Tan is always 1 to 45 and stuff like that. I don't know. You can use this method if you want, of course. It's helpful. It was helpful for me when I was like 14 doing my GCSEs. But basically, that's what that refers to. If you ever hear that word shout around. So basically, we're looking at this bit for this problem, right? So sine is O over H. So we're just going to set that up equation, putting all the information into the equation. So I know that sine of 30 degrees is over H. So that's going to be 3 over x. Okay. So I want to find x. I know that sine of 30, if I plug that into a calculator or just remembering the value from our table before, it's equal to half. And then, after I've set it up, it just reduces to solving this simple equation. And then I get x is 3 over 2. So x is, sorry, no, not 3 over 2. X is 6. X is 6 centimeters is what I would get there. Okay. What about a different question? Let's say we had, let's say we knew that the hypotenuse was 5 and this angle was, I don't know, like 10 degrees. It's not actually, but geometrically speaking, my diagram is not drawn to scale. Let's just throw that disclaimer out there. And I want to find this side x, okay? So again, I'm going to set up I'm going to label what sides we have. So I have the hypotenuse, I have the adjacent here. So I must use cos. So cos of 10 degrees, setting the relation up, is a over h, so that's going to be x over 5. So rearranging that to make x a subject, I just get x is 5 cos 10. Cos 10 is roughly, roughly 0.9, maybe 0.8. So I just plug that into the calculator and I get an expression out for the answer. But that's kind of how we would use these things. Let's do one more example of tan just for completeness. So let's say this side was 4. I don't know this side, and I know that this angle is 20 degrees. How could I work at that side? Well, that's the opposite, that's the adjacent, so tan of 20 is opposite over adjacent, so it's this thing over adjacent, and I found out that the thing in question must be 4 tan 20. Just by rearranging it. So that's what this side must be. Okay, I hope that's clear, how to use these sine, cos, and tan to find various sides in a right angle triangle. The next thing we're going to talk about is actually using them to find the angle. But before I do that, you need to know how to invert the function. So in the next video, we'll talk about the inverse functions of sine and cosine and tan.